Okay, so today let's talk about irrationality measure. It is defined as mu x equals to infinite a times this thing smaller or equal to 1 over q with the power of alpha only has integer solution pq where q must be a positive integer. So the first property is that if irrationality measure of x is mu, then for all epsilon greater than 0, number of solution of absolute value of x minus p over q is smaller than 1 over q with the power of mu plus epsilon is infinitive, while the opposite side of the inequality has infinitive solution. There is several theorems for irrationality measure. So first, for irrational algebraic number x, mu x equals to 2. For x belongs to real number set, mu x equals to 2. Also, if x satisfies for any n belongs to the positive integer set, then there exists pq where q greater than 1 belongs to integer set such that 0 is smaller than absolute value of x minus p over q smaller than 1 over q with power n. Here is some here is a fun property here. There is several approximation made by some people before. You can see it here. So let's take a look at some exercise. So actually, we from the approximation, we know that mu pi is smaller or smaller or equal to 7.104, and we know that the absolute value of pi minus p over q smaller than 1 over q with power of 7.5. Solution is number of solutions is infinitive. So it means that there exists a big N greater than 0 such that a small n greater than larger n, that we always have absolute value of n minus k pi greater than 1 over k with power of 6.5. Then for any smaller n greater than larger n, there exists a integer k such that The absolute value of n minus k pi belongs to the interval of minus pi over 2 and pi over 2. Therefore, we have the absolute value of psi n equals to psi n minus k pi absolute value larger or greater than 2 over pi times absolute value of n minus k pi greater than pi k with power 6.5 here. And from n minus k pi greater than minus pi over 2, know that k is smaller than n over pi plus 1 over 2 is smaller than n. That means 2 over pi n 6.5 is smaller than absolute value of psi n, smaller than 1. And then we can just add a power of 1 over n to both sides. And by sandwich form, we know that the limit of n tends to infinity with the absolute value of psi n with power of 1 over n equals to 1. Okay, let's take a look at the second questions. So similarly, for suffocatingly large p, we always have absolute value of q times pi minus p is greater than q with power of 6.5 here. Take q equals to 2k plus 1, p equals to n, then n the absolute value of n minus k plus 1 over 2 times pi greater than this. For any n, there exists a case such that n minus k plus 1 over 2 pi belongs to the interval. Therefore, there exists a larger n larger than 0 such that for any n a small n larger than the larger n, we have such inequality. Therefore, the absolute value of 10 n over n with power of 8 power of 8 equals to this, which can simplify further to oh, there's nothing to simplify further, so. And we can find the limit of this thing is 0. And actually, we have further inequality relation. So the limit is 0. The limit of this thing is 0. And we are done for this question. So for question 3, for question C, it is actually an open problem. And we can convert this form into a more well-known open problem. So the equivalent open problem of these questions depends on if e plus 2 pi 1 here. E plus 1 over 2 pi is rational or irrational. So let's assume E plus 1 over 2 pi equals to P over Q, where PQ is a positive integer such that their greater common divisor equals to 1, which means they are co-prime. When n is larger than q, psi n factorial equals psi 2 pi n factorial times p over q minus e equals to negative psi 2 pi e n factorial equals to negative psi 2 pi sum k equals 0 to infinitive. Then we can continue okay, so consider the sum here. The sum here is actually greater or equals to n plus 1, n plus 2, 1. Furthermore, we have limits n tends to infinity 2 pi over n plus 1 plus 2 pi k from n plus 2 to the infinitive 1 over n plus 1 multiple by many value until the k equals to 0. So we can imply that such limit equals to 0 only if e plus 1 over 2 pi is rational. Okay, let's look at the question 2. It is an open problem as well. By the method we used, we know that for all epsilon greater than 0, there must exist n larger than 0 such that for any small n larger than the greater n, there exists a positive integer k such that the absolute values of n minus k pi belongs to interval of this. Where the mu is the irrationality measure of pi. By the previous question, we know that absolute value of psi n equals to psi absolute value of n minus k pi belongs to this. So, if the given sum converge, one over crib n and square of psi tends to 0. And we have this. And then mu smaller than 2.5, but this is actually unproved. So today we have covered the content of irrationality measure and its application to some context problem you may face. So see you in next video. Bye bye.